So let's create the script using Visual ETL, and just wanted to show you that in the connections, I do not have anything. In the job details and in the connections, neither I have the Aurora connection nor do I have the Redshift connection, because it would be automatically picked up the moment we add the nodes for those. All right. So first, sources, and we definitely need that. We need the transaction table, and it would be from Glue data catalog. It would be from Aurora MySQL Finance DB transaction, right? So this is what we are adding. And there are a lot of fields in this transaction table. I don't think we need all of them. Let's look at the Redshift table once. We need the transaction ID, source account from transaction table, customer name and customer country would be retrieved from customer table. We need the destination account, the transaction amount, the transaction date, and cross country flag is something that we will add in the condition. Okay, so let's select only those fields, and for that you already know that we'll have to have a transformation which would be a select transformation, and this is the one, select fields. Okay, so this is the name of the node, and let's select the fields. We need transaction ID, transaction date, source account ID, amount. The transaction status is not needed, destination account ID is needed, and these are the only fields that we need. All right, so once it is done, so we'll have to join with customer table. Now we need the customer details for both source account and destination account, because you have to find out whether the transaction is a cross country transaction or not. So we'll have to join with customer table, or rather the account table, to get the customer ID, and from there we'll get to the customer table. Because let's open the Glue data catalog, and here let's look at the tables. So first is the transaction table. We have these fields, transaction ID and the account IDs. Now if I go to the customer table does not have any account ID, right? It is a standalone customer table. So it is national ID, country, etc., and then there is this customer ID. There is no account or transaction ID here. So I'll have to join with the account table, which is finance DB account. Here we have the account ID and the customer ID, right? So we need only the customer ID from the account table, and we'll be joining with transaction table based on account ID. Now there are two types of accounts. One is the source account and the other one is the destination account. So you'll have to get the customer ID for both the source account and the destination account. So let's do that. Have to add another node, and that would be a source from Glue data catalog. It would be a source account table from the data catalog, which is finance DB account. That's all. Now let's add a transformation node wherein we'll be joining this node with this node, meaning that we'll be joining the selected fields from transaction table with the account table. So let's add this join, and there should be two nodes. So it should be joined with the selected fields and the source account table. All right. So it would be an inner join. So let's add the joining condition. So the first joining condition would be actually the source account ID. So I'll have to get the customer ID wherever the source account ID is equal to the account ID in account table. So in the source account table, I'll use the account ID, and in the transaction table, I'll have to use the source account ID, right? So this is what we are doing. So we are joining these two, and I'll be adding one more transformation, which is select fields, because we do not need all of them. So we'll be selecting the fields from here, and let's see what fields we can select. All right, so we need the account ID for sure, the balance, the customer ID, the transaction ID, transaction date, source account ID, amount, and destination account ID. We do not need the balance. We need account ID and customer ID. In fact, we do not need account ID also. So this is what it is, and we'll have to rename some of the fields. Actually, I'll be renaming only one field. So this would be a source customer ID. So let's use this rename field. I'll be selecting the customer ID and I'll name it as source customer ID. That's it. Let's save it. Okay, our DAG has already become a little big. That's okay. So that's why I think PySpark is much easier than using the visual ETL or the no code experience. Okay, now let's see what is the output schema from this. So I can look at the output schema here. What it will show you what are the fields that are going to come out of this data frame. Essentially, it is a data frame. So you have the source customer ID, transaction date, source account ID, amount, and destination account ID. So we'll be joining again with customer table. You'll have to do that because you'll have to get the destination customer ID also. So let's do that. I'll be adding a join transformation and I'll be using the account table, right? So this is the other. So the account table is input to two different transformations. The reason you already know. For this join, I'm joining using source account ID. This is the transformation, and in the latest transformation, I'll have to add the destination account ID, right? So let's select the destination account ID and the account ID. All right. So again, I think we'll have to have one more select fields because we do not need all these. So let's add one more transformation with select field. All right. So this is done. And now we'll have to use a rename transformation. I can search it here also. So this is rename field. So I'll be renaming the customer ID as the destination customer ID. That's it. All right. So now we have this DAG wherein we have source customer ID, transaction date, source account ID, amount, destination account ID, and destination customer ID. Now I'll have to get the customer information. So for that, I'll have to join this one with the customer table. So I'll add the nodes and come back when the joining is done. All right, this is what I have done. This is the select fields, and after that I have renamed the column country to source customer country, and then I have joined this particular table with the customer table again. The reason is because I wanted to get the customer country also, right? And then after that I'm selecting the fields, whatever fields are needed. Because I have joined with customer table, I do not need all the other columns of customer tables. After that, I have renamed one column, which is the country column. It has to be destination customer country. And then, interestingly, I have added an SQL query. Now, why I have added it before putting it in the Redshift data warehouse? Reason is because the Redshift table that we have, it has transaction ID at the beginning, then source account, SRC customer name, SRC country, and so on. So there are two things that we have to consider here. The first thing is the ordering of the columns. The transaction ID should be first, then the source account ID second, then the customer name, then source country, etc. So the ordering has to be exactly same as that of the target table, which is true for OLTP also. Whenever we write a data frame to a OLTP database or NoSQL database or data warehousing system, we'll have to make sure that the column order is as per the target table. So that is the first consideration. The second one is that the name of the columns are like this: txn underscore id, src underscore account, src underscore customer underscore name, etc. So you have to do two things. First is reordering the columns, and the second one is renaming the columns. Unfortunately, Glue does not have any transformation which will reorder the columns. So that's why I have used this SQL query transformation or SQL query node. And here you see what am I doing is that the input source is dest customer rename, and I have created an SQL alias as df underscore final. We have to do it, otherwise it will give you error. Now inside of this SQL statement, I am just performing a very simple select statement wherein I'm selecting transaction ID, and at the same time I'm renaming it as txn underscore ID. Similarly, the source account ID has been changed to src underscore acc. I have not provided the source customer name, and I have provided ELT here, meaning that maybe you'll be loading the record and then we'll do the transformation, or we'll join the records in the OLTP database from Redshift using federation and then get the customer name from the customer table, which is there in OLTP database. Similarly, I have source customer country as SRC country, destination account ID as the destination account, and so on. So using this select statement, I have not only renamed the columns, I have also ordered the columns as per the requirement in the Redshift table, which is cross-border transaction count. The reason is because we are loading the cross-border transaction count table. So you see, this is the table that we are loading. So we have to make sure that the column order and the name of the columns in the data frame or dynamic frame in case of Glue should be similar as that of the target Redshift table. Now before execution, let me show you the number of count in this table, cross border transaction count. Currently there are no rows or no records. So once I run this, then of course it would be added. The records would be added. So the transformation or the entire ETL job would be complete. So the DAG that we see here is kind of a little complex, but if you run it using PySpark, it would be much easier. Let's try to look at the glue script, and the glue script is also pretty complex. At the end of it, we have the SQL query, and it is writing to the Redshift table using this Redshift connection. Let's look at job details. Now the connection for Redshift should also be added automatically. So you see here, it has been added. Now let's go ahead and run this. It might take some time to run the job, maybe 7-8 minutes. Once the execution is complete, then we'll be able to see the records in the Redshift target table. So I had run it multiple times just to do the testing in Glue. So this is the final execution. And once this execution is completed, the Redshift target table that we have created or that we are planning to load will be loaded once the Glue script is complete. Okay, the execution is complete, and let's go ahead and look at the number of records. So 192 records have been loaded, and let's do a select star. And we have all the records as it is. So we have transaction ID, source account, source customer name, source country, destination account, destination customer name, amount, transaction date, etc. So I think there's some problem with the transformation. There are a lot of duplicate records. Of course, we can remove it. To do so, we'll have to add one more node here to remove duplicate records. Anyway, I hope you've got a sense of how to use Glue API in ETL to load records from OLTP databases to OLAP database.